In this section, we'll learn to do hypothesis testing in ANOVA. The process for doing hypothesis testing is as follows. Step 1. Formulate the null and alternative hypothesis and draw the F-test diagram. As ANOVA is about comparing population means to see if different groups within a factor has any effect on a dependent variable, the null hypothesis would look something like mu sub 1 is equal to mu sub 2 is equal to all the way to mu sub k. And the alternative hypothesis will state the opposite spectrum, whereby the population means are not all the same. To draw the F-test diagram, we draw a positively skewed diagram with the right tail shaded. In our earlier example on freshman, junior, and senior, since there are three groups, the null hypothesis should be mu sub 1 is equal to mu sub 2 is equal to mu sub 3. And the alternative hypothesis should be where the population means are not all the same. To draw the F-test diagram, we draw a positively skewed diagram with the right tail shaded. For step 2, we specify the level of significance alpha so as to find the critical value. Alpha corresponds to this shaded area under the right tail. Critical value is this crucial point that divides the rejection region from the non-rejection region and is labeled F sub alpha. It is determined based on the F distribution value corresponding to a specified alpha, with k minus 1 degree of freedom for the numerator and n minus k degree of freedom for the denominator. In our earlier example, alpha is equal to 0.05, and this is the right tail rejection region. To get the critical value, we note from our summary table for ANOVA that the degree of freedom for the numerator is 2, while the degree of freedom for the denominator is 15. And hence, this value of F sub alpha with 2 degree of freedom for the numerator and 15 degree of freedom for the denominator is the number we need to find from the F distribution table. Using the F distribution table, F sub alpha with 2 degree of freedom for the numerator and 15 degree of freedom for the denominator is equal to 3.68. And this number separates the rejection region from the non-rejection region. Next, step 3. Determine the test statistics. F star can be calculated by taking group mean square divided by the mean square of the error, which can be found in the summary table for ANOVA. In our earlier example, we used this formula to find F star. From our summary table for ANOVA, the group mean square is 11.5556, and the mean square for the error is 1.5445. Hence, F star is calculated to be 7.4818. And finally, step 4, draw the conclusion. To do that, find where the test statistics F star is located in the diagram. From there, the decision rule should be as such. If F star lies in the rejection region, we reject H naught at level of significance alpha. If F star does not lie in the rejection region, then we do not reject H naught at level of significance alpha. In our earlier example, F star is equal to 7.4818, which lies somewhere around here. Since it lies in the rejection region, H naught is rejected at alpha equal to 0.05, and we conclude that the means are not all the same.